Okay, so after the first week, we started talking about research methods, and we went through all those steps, and we're focusing on how to analyze data in this class. Remember, there's two branches of statistics. One was descriptive statistics, which we have gone over already, and one of the branches of descriptive statistics is univariate statistics, which means just one variable at a time. So calculating the mean or standard deviation are some examples of univariate descriptive statistics. Then we had bivariate descriptive statistics, which is about the relationship between two variables. So a correlation is an example of that. Then we went over probability, and probability will help us in the upcoming phases about inferential statistics. And inferential statistics is about when we want to make inferences about our population of interest with our sample. So if you go over here in this, look here, say the United States, which is at the top, is the population of interest. We want to know something about everyone in the United States, but we can only contact these people in our sampling frame. So these are only people we have, say, phone numbers for. That's our sampling frame. That's who we can pick from. And those are some people in the United States. And then we randomly pick, or we might not randomly pick, it might just be a convenience sample, some people, and that makes our sample. And from that sample, we want to make an inference about the population, but we only have sample data. And we're going to use probability to help us make kind of educated guesses about our population of interest with just a smaller sample. And for inferential statistics, there are two main types: confidence intervals and hypothesis testing. In this class, the confidence intervals and hypothesis testing will be what are called parametric tests. There's some other non-parametric tests that we won't go over, so this doesn't cover every statistic test that you can do. But a parametric test, and what we're going to focus on in this class, have a scale outcome variable, so some kind of numeric outcome, something to do with numbers as outcome, and also the central limit theorem must hold true. And if you remember, there must be a normal population distribution or a sample size of 30 or more, and we need random sampling, but this is usually not true. We kind of relax this assumption of random sampling, but we want to kind of make sure that the sample is not biased in some way. So say you want to know the ACT scores of everyone in the United States, or everyone who is in college in the United States, and you only sample people from Harvard, you're probably going to get a higher estimate of ACT scores than if you had a random sample. So that's probably a biased sample. And sometimes your sample will be biased, but you just have to kind of know it and list it in your limitations if you're a psychologist. And people will realize, okay, it's not a perfect study and no study is perfect. You just have to realize that, okay? So hopefully at least your sample is not biased in any way, because you hardly ever get a random sample, because first you can't contact everyone. Say in the United States, you don't have all the college students' emails or contacts. That's one thing. And also people might not want to tell you their ACT score. Might be private for them. So you're never ever going to get a random sample. A truly random sample list. It's a small population. So first thing we're going to go over is confidence intervals, and this estimates population parameters. And we're going to start with estimating the population mean with the sample mean. So we're only going to have one sample at first. Later on we'll have more. And the mean sample mean is not a perfect estimate of the population mean, right? It's going to be a little bit off. So what we do is we kind of put a range on the confidence interval. So here's an example of a confidence interval. So with 95% confidence, the population average height of men is between 5'9" and 5'11". So we're kind of estimating the population average height of men. We put a range on that. We're not 100% confident that's going to be between these two numbers, but we're pretty sure that the population average will probably be captured in between these two numbers. Okay? So we're just putting what's called a margin of error, and they do this a lot in politics when they do polls. You might have heard of that term, margin of error, if you listen to politics a lot. The other type of inferential statistics is hypothesis testing, and this is when a researcher has a certain hypothesis that they want to test. So confidence interval is just estimating a population parameter like the population mean, and hypothesis testing is similar, but we have a specific hypothesis that we're testing, and we test it with the sample mean, but we're really making our hypothesis about the population mean because that's what we want to know about. And we make an inference about our population mean with data from our sample. An inference is statement about the population based on a sample. So here's an example of an inference for a hypothesis test. It says at the 5% significance level, we can conclude that the average height of men is greater than 5'4", which is actually the population height of women. So this is one example. I'll go into more details about that.